Hi, I've been a fan of Matlab ever since I was an electrical engineering student. Especially of Simulink because it allows you to draw circles and squares and they mean exactly what you want them to mean. But then I changed to computer science. And the squares and circles in computer science mean different things than they meant in electrical engineering. And now Matlab didn't support me anymore. But a few years ago, they started to add computer science-like modeling formalisms like Dataflow, and very recently Simulink SimEvents. And with the SimEvents toolbox, it has finally become possible to draw token-based systems using Matlab Simulink. In this video, I'm going to show you how that can be set up. And I'm going to show you how you can use a custom-made block to draw Dataflow diagrams in Matlab Simulink so that you may get a better feel for what Dataflow models are like, and you can play around with some models yourself. The first thing that you need, of course, is to install Matlab. And you need the 2016B version, which is very recent, because my code will not work on any earlier version. Once you've installed that, then you can go to my website, www.win.tui.nl/wigglything pkuiper without the S /Dataflow with a capital D .zip. And when you open that zip file, you get two files, namely a Dataflow file, dataflow.m file, which contains my Matlab code, and a Dataflow example file, which is a Simulink file that I'll show you later. And you copy those two files to the Matlab working directory, and then you're good to go. So now we can start up Matlab. Once you've started up Matlab, you start Simulink, and you open a blank model. And then something important comes up, because once you've opened a new model, because we're going to use a custom block in SimEvents, we need to do something special. These custom blocks, they communicate their tokens via buses, and that bus needs to be put into the model manually. So you go to Edit, and you go to the bus editor, and then you add a bus. You rename it to token, because that's the name that I've hard-coded into my blocks, is the name for the bus on which tokens are communicated. Click Apply. And then you add a bus element, and you give it a name, and it's really not important what name it is, so I call it ID usually. And then we are good to go. Now we can open the Simulink library, and we can go to the SimEvents section. And in the SimEvents section, look for the discrete event system, which is the custom block for event-based modeling. We drag that to our model. Now, because we have added Dataflow.m to our working directory, once we double-click the model, we only need to select Dataflow, and then we have our first Dataflow actor in Simulink. If we double-click the actor, we see a number of parameters, and the first parameter, there you can give a vector, and the number of elements in that vector determines the number of inputs of your actor. So if I make this 3, then my actor will get 3 inputs. If I put 4 elements in the output rate matrix, then my actor will get 4 outputs. And the rates of these outputs and inputs, so the number of tokens that is consumed with each firing and the number of tokens that is produced with each firing, is of course the number that is specified here in that vector. Then the initial tokens are treated a little bit differently in Simulink than you're used to in the Dataflow graphs that I draw in my course, because in Simulink you cannot draw anything on arrows, so we have to do it inside the block. Now, each input gets a number of initial tokens, And if we have 3 inputs like we specified over here, then we also have to specify three elements in this initial vector. So let's say that there's 5 initial tokens on the first, 0 on the second, and only 1 initial token on the third input. Then we only need to specify the delay, or the time that the firing of this actor takes. And we can specify both a maximal value and a minimal value, and the actor will actually pick randomly one value between those two numbers for each fire. If we then click apply, then we see that the icon of the actor has changed a bit, and you can see for each input the rate of that input, and between brackets the number of initial tokens, and for each output also the rate of that output. And here in the middle it says 2 to 5, which is of course the delay, which is between 2 and 5. It also says that we're dealing with a multi-rate actor, because if now I change to a very simple setup with only 1 input with rate 1 and 1 output with rate 1 and only 1 initial token, and it has a minimum delay of 1 and a maximal delay of 1, then it says it's a single rate actor, and it also doesn't show the rates anymore, because in a single rate actor that's trivially 1, and it only shows 1 value here for the delay, because the delay is only a single value. The minimum and the maximum delay are equal. Now if I add true here at the end instead of false for show signals measuring state, then something happens as well, and that's that the actor gets 2 additional outputs. Now this first output was an output that carries tokens, which is indicated by a rather thick arrow going now from input to from output back to input, because I just drew that self cycle. But these 2 outputs are ordinary Simulink signals, which means that we can measure them, for example, using a Simulink scope. So let's open the library browser again, go to continuous. Let's search, because I always have to look a little bit where it is. Here in commonly used blocks there is the scope, and we can add the scope to our model. And this first output signal gives us the number of firings of the actor over time, and the second one gives us the number of elements in the buffer over time. So the simulation time has been set to 10. If I now just click run, then my simulation runs, and I can look at the scope, and I see that it immediately starts by jumping to 1, and then it adds 1 every second, because 1 firing happens every second if I set it up like this. And the scope that shows me the buffer shows that the buffer that was always a token in the buffer, except of course when it goes out and then goes back in again. Now this is a very simple model. Of course, if you want a more complicated model, then we can close this one. No, we don't need to save it. And we can open up the example that came with this block. And this one you can study for yourself, but this shows a Dataflow model of a sample rate conversion in 2 pipeline stages. This is of course a source that gives a number of tokens per second. This is a sink that actually receives a different number of tokens per second, or tries to receive a different number of tokens per second. And these are 2 multi-rate blocks that perform a conversion in sample rate. And I did something special here, namely I've multiplied the outputs of the firings, because a single firing of the output actually corresponds with the number of firings of the input. So I put a multiplication factor here to make the outputs comparable again. And if you then run this and you look at the scope, then you see a very nice graph. Let's see if I can make it. Yes. a very nice graph in which the output and the inputs are shown, the number of firings, and of course you can read latencies as the horizontal displacements and bufferings as the vertical displacements, and the throughput of several of these as the slope at which those lines happen. Well, this is a nice model to experiment with. I hope that it's clear now for you how to set up a data flow model in Matlab Simulink, and that you're inspired to try some model of your own, coming up next. Have fun, and I'll see you back in the course.